Welcome back, everybody. This is part 3, the final installation of this series of the Hallicrafters S-38B Bravo. I had talked about maybe doing a video on a modification of adding a BFO, a beat frequency oscillator, but I chose not to. This one is working okay for what type of receiver this is. I can copy CW, I can copy single sideband. It's not the greatest in the world, but with the adjustment you'll see in the upcoming video, you'll see how you can calibrate the BFO that's in there. And so I was able to make it work adequately for this particular type of receiver. This is not a great communications receiver. This was a kind of a starter thing, and it's a lot of fun to play with. And I was going to demonstrate it, and they probably will once this storm passes. We've got a thunderstorm. It's the 20th of August 2025, and we've got a storm coming through with a lot of lightning, and you may be able to hear the static crashes on the radio, and it's just too noisy to even demonstrate right now. But I appreciate everybody watching this series, and if you like it, hit the like button, and so sets the algorithms up for other folks to do it. Make comments, good, bad, whatever, and I always enjoy the comments. And like I've always said, I try to answer each and every one of them. Sometimes I'll miss them because I don't get notification. I'll blame YouTube on that, but sometimes it just slips past me. But I really try to answer every one of them. And that's what I want everybody to do. Look at the comments. That's one of the things when I watch other people's videos, I go through their comments and watch. You can learn a lot of stuff from other comments. Now sometimes you have to sift through it to get the information, but they're entertaining as well as the video. So sit back, let's get to finish this thing up. Okay, told you I was going to go back and try to replace some of these capacitors, and so while I'm in there, I went ahead and put a safety cap right here, because that's one of the lines going to ground, so I made that a safety cap. There'll be another one up here. Let's see, where is, this one right here will be replaced with a safety cap also. This goes from the line, even though it's going to be neutral, it goes to the external cabinet, so I'm going to put that as a safety cap also. If you'll notice, while I was in there, this is just the resistors. I would check them, and if they're pink, they were out of tolerance, and means I'm going to change them. And I wrote beside them, of course, this it's a capacitor, but it's pink. I was going to change it. The blue ones mean they're within tolerance, and I wrote the value that I got beside it. And even if it's pink, like say up here, I wrote the value, and I will denote it when I do change them out. So I've got a list of resistors where I go to workbench number 2 and get my resistors, and some capacitors down there. I usually keep capacitors in both workbenches, but the resistors I don't change that often. If I do, I get a list. So that's how I do it, is I go through it, I check them. The ones out of tolerance, I paint them pink, and then I go get a list, and then I'll come back and change them, and then I'll denote that I changed them. And then I'll go through and change all the capacitors while I'm at it. All right, changed several resistors. Got them marked on the schematic. I put a safety cap here, which that is, I showed you I think earlier, where that ties at least the neutral line to chassis ground, and then this is the capacitor that does the cabinet to chassis ground. So I made that a safety cap as well. I've got all the caps. I'll go back through here and found quite a few resistors out of tolerance. Let's see, 1, 2, 3, 4, 5, at least 5, 6, 7. I found 7 out, and so I changed those. And so I will bring this back up on the Variac, and we will play it and see what it does. I asked around about this composite capacitor in this area here, and I couldn't find where anybody had changed it or didn't change it or left it in or whatever. So I was doing some troubleshooting, had a little hum here and there, so I started tracking through it. I never found anything really wrong, so I just went ahead and replaced it. And here's what it looks like, and this is how it's built inside there. So I just took those values and wired it up in the circuit like that, and it's all in this area right in here. There's everything's recapped. It's playing now. Seems to be doing okay. And now we're going to do an alignment. It's doing really well. It's receiving really well. Not so well on the higher bands, but that's to be expected, I think, especially if it's out of alignment. So we're going to go through the alignment process and see if we can figure it out. The one problem I already see with it is that you're supposed to put the band selector on 1 megacycles, and I got a radio station at 970. So we'll see. It's a pretty strong station, so we may, I don't know, we may have to skip up a little bit and calibrate on 11 or something like that. I don't know how that would work out, but we want to get a good reading. So let me set everything up. I'll be right back, and I'll bring you guys back. Okay, as per the instructions, you take your signal generator and you put it on 455 kilocycles, which I've got that. The band selector is on the broadcast band, which is number 1. You set the receiver dial setting to 10 or 1 megacycle. And as you can hear, we've got a little bleed over from the radio, which this should maybe it won't interfere with it, but we'll see. We'll see how that works. And then we want to adjust A, B, C, and D, which that's the I of cans, and I've marked them. This is A, B, C, and D. And you adjust for maximum audio output at the speaker voice coil. Use just enough signal output to obtain 50 milliwatt reading on the output meter. Okay, we're just going to use the voltmeter. And the high side on the front, it says, I believe, on the front section, that's the high side here, I believe. As you can hear that. Let's see if we can. Yeah, we've got a little. Trying to get a little output there. So I have one. So let's do some tuning here. See if I'm in your way, probably. Here's A, my tool will work. That was pretty much seemed to be okay. Yeah, this one's going to be a little difficult because it's a little off center here. Let me bring you back. I was able to tune A, B, C, and D to get the maximum. And I've got this turned down pretty good up here. So I believe we've got the first step done. Now the next step is a little tricky. And then let me get rid of the noise and everything, and I'll come back and explain. Now the setup says same as step 1. It says step 2 is usually unnecessary. Adjustments should be made only if a weak beat note is obtained on strong CW signals, indicating a lack of coupling between wire echo E and pins 4 and 8 of the 12SK7. This is doing the beat frequency oscillator. So what it says is we need to set the AM CW switch at CW, and then we reset it at AM when step 2 is completed. Make sure you do that. For the correct BFO operation, vary the coupling between wire E and pins 4 and 8 of the 12SK7 tube for a maximum beat note. Pushing the wire towards E towards pin 4 increases the strength of the beat. So I take it that pulling it away. Well, this is wire E right here. Comes from the circuit up here. And then it goes and loops through pins 4 and 8. Okay, so moving this wire is going to affect the beat of the BFO. So I'm going to try this off camera first, because this is moving things in here that's is energized, and I need to be concentrating on it and not filming. I hope, and then I'll show you exactly what I did. I'm going to listen to it when I turn it on. Let's see, we can do that much, and let's turn it down. Just barely can hear it. And then we're going to adjust this wire to see if we can get more or less of a beat. Let me do this because I need to be focused on this. I'm going to try to put this on film without getting myself electrocuted. And think about this. If you do this, you're doing it at your own risk. But by moving this wire, turn this down a little bit. And the instructions say for pushing the wire towards the pin 4 increases the strength of the beat. Let me make sure let's see. 1, 2, 3, 4. Let me make sure which is pin 4. Alright. As you can see, as you move this wire, it changes. So what I've got to do is find it and put it in a place that it's not going to move much, where I have the highest pitch there. It's going to take me a while to do that, but I'll bring you back when I get it done. I moved that around quite a bit. And I got it really, really strong there. So, okay, what I did is when I found the spot, I put a tie wrap on it and left it alone. So we'll see how that works out for us. So let's go on to the rest of it. And of course, it says afterwards, flip it to AM again. So we still got our signal there. I kept hearing, you can hear a little bit of, that's a heterodyne on that AM station. That may affect us some on the tuning, but it's doing what it's supposed to do. It's beating a tone against the signal. And when you go to CW or single sideband, you inject that signal and you'll get that CW tone. All right, let's go to the next step. I believe we got to leave the belly up for this. Okay, on the next side, we're going to do the 30 megacycles, which is step 3. High side on to A1 on the antenna strip through the RMA dummy antenna, which they describe it up here, which I've had one. I've done several receivers with this. The standard RMA dummy antenna consists of a 200 microfarad capacitor, or I'm sorry, 200 picofarad capacitor in series with a 20 microhenry choke, which is shunted by a 400 picofarad capacitor and in series with a 400 ohm resistor. So there's that, and I got to hook it to the A1 of the antenna. On the back there's A1 and A2 and a ground, and so we connect the jumper between A2 and ground, and that's as if it's like a long wire or a doublet, I believe. Anyway, we want our band selector on number 4, and we want this on 30 megahertz right there, and I want the frequency or the signal generator on 30 megahertz. Let me get all this hooked up on the back and we'll go from there. We're under the belly of the beast now. We've got the high side of the A1 antenna strip through the RMA dummy antenna. I showed you the resistor, inductor, capacitor that I have put together, and the ground side to G, and the G or the ground and the A2 antenna, it's got a bar on it, so you take that. We've set their signal generator to 30 megahertz, and we're on band 4, and we need to adjust F and G for maximum output as in step 1. Okay, I don't know if you can see this or not, but F, this is the front, so this is going to be backwards. F is this one here, and G is this one here. So we need to adjust these two for maximum. Let's see if we can get something. And we're on AM. was getting some hum through my signal generator and my frequency counter, so I disconnected the frequency monitor. I said on 30 megahertz, and unplugged the frequency monitor, and then the hum went seriously away, so that's a good thing. So I think we can finish this step. Real touchy. I'm looking at the meter. We're getting some buzz. I don't think we want that buzz. Turn that down a little bit. Alright, I think we're getting really close. See how just a little bit it stops oscillating up here on the high frequency. I think we're going to leave that there. Then we'll go to 14 megahertz. Got that set to 14 megahertz, and we want to do H and J. Take the pressure off of it and it jumps. It helps if you get it in the slot. I think that's going to do it. Let's go to the next step. Okay, got it set on 5 megahertz, and we want to go K and L. back through the, I'm bringing it down, I'm going to bring it back up to the compression side as for peak. There you go. Let's do the same thing with this one. Went through it. I believe that's going to be it. Let's go to the next one. All right, now we're on the broadcast band, so I've got it set for 1500, and so we're on band 1, so we need to do M, N, and P. So here we go. That didn't have any effect on that. Okay, let's go to 600 kc. So it'll be down here, and so let's see where we're at. That's 455. At 665. Let's see which one brings it down. It doesn't tell which one. Okay. Let's go back to 1500. I think I've read the instructions better. We'll go to 1500 up here. Which one? Here we go. Should be right there. I think what it's telling me to do is for 1500 to do M and N, and then for 600 to do P. I turned P, so that's the reason it was on 665 instead of 6 when I went back down there. I think I turned it, and that's the reason. So we need to tune this one and this one for max. And I think we did. Just doesn't hurt to check it again. All right. Now we go down to 600. Right there, and make a real calibrated dial with that wide mark. Alright, that was you. Okay, now we'll go up here. Okay, there's 600, and if we find it, it's on 670, so we're off, the dial's off, and let me, okay, there's 670, so let's go down to 650 and turn P and see if that brings it down, and I think that's what it does. Yeah. Alright, let's go on down to 600. That seemed pretty tight. I don't know if it's going to go on down or not. Make sure I'm lined up correctly. I am not. That's the problem. Duh. Right there is 6. With so many dials, it gets confusing sometimes. Okay. All right. So let's see if we can bring this back. Okay, there's the tightening part of it. That looks good. Let's go back up to 1500. Let's see. No, I'm way too high. You may fast forward through this. There's 1485, 1500, and let me look and see if I've got this. I think that's on. I had to touch the dials. So I think we've got it aligned. So let me disconnect everything, put an antenna to it, and put it through its paces and see. I said I was going to put ends or some sort of connectors on these wires, and so I found these connectors down in a drawer, and they fit exactly on those tabs. I cleaned those tabs up, took the solder off of them, and these plug right onto that speaker. That'll make it easier for some other person somewhere down the line to take it out. Who knows, it may be me one day. Let's go over what I did to prepare the cabinet ready for put the chassis back in. I cleaned the plastic windows first, and then I decided it had a little bit of scratching, so I put a little bit of number 2 Novus on it and got some of them out. I didn't do a whole big production of getting every scratch out of it, because as long as you can see through it, it's fine. Because this is a 75-year-old receiver, and the Smithsonian turned me down. They're not going to take it. But it should be a fun receiver, and it should look halfway decent. Now, what I did is kind of unconventional, and some will mock me and some will criticize me, but what I did is I pretty much masked off the front of it, covered this up, and also the inside, so I didn't get any overspray. And then I took some flat black, and then I sprayed the rest of the cabinet. Okay. Then I had a mismatch from the new spray and the front. And I've used this trick before. Let's see, I don't have all my lights on either. I don't know that that helps any or hurts any or whatever. But anyway, what I've done in the past with metal painted radios is I have used baby oil. Now, some say that will attract dust, and it will. But it will do a couple of things. It will bring out the luster of the metal and the paint, and it also will protect any rusty spots which are in here. And since it was mismatched there, I covered all of it with oil. Now, a little unconventional here. I didn't use baby oil. I use 3-in-1 oil. Now I'm sure I'm going to get some pushback on that, but it looks pretty good. So even I think it looks as well on video as it does in person. And usually people that know that a lot of times the video will make it look a lot better, but in this case it looks pretty good. The other thing, you remember the adolescent beavers that had dull teeth? They gnawed the edges off the knobs. Well, I took and put that on a took those edges off with a sanding belt, and then buffed them to where now they're smooth. Still not perfect, but it doesn't look like beaver's been a hold of it. The other thing, and some of the other folks, other videos I looked at, they didn't know how this this band selector, how it lined up and everything like that. Well, on this one, it had a red dot on the knobs. Don't know if you can see. Of course, it's not a red dot anymore. Let's see if we can get a better picture. So what I did is I took both of those, and there's an indentation there, and I took some white acrylic paint and I put a drop down in there, and then I took a paper towel and wiped it off and let it dry. So now the volume control and the selector switch will have a white dot. So I think we're ready to start putting this back together. Let me put it back in the can, and I think that's the only thing I need to show you. I'll show you the back when I get ready to put it back on. I cut the hole a little bit bigger to allow our new power cord to pass through it. Okay, when you go to slide these in, I've connected, I put the plugs on the speaker and slid it in, and the other thing is you have to reach over the edge of a table. This way I did it. And make sure you align these switches, one for the AM CW speaker. Try to line those holes up, and you may have to raise one side up or the other to get them, and then we get those screws in there, and then we can go on with the knobs. Okay, I kept those plastic tabs in place on the inner chassis. So it's still going to be isolated, but we do know that it's got a neutral ground if your house is wired correctly. I used a little bit longer screws here than original. They didn't want to hardly make it, and it may be because of some bowing on this particle board bottom. So now let's put the back on, and then we'll try it out. Okay, see, I made the hole bigger, slot bigger, then took a magic marker and made it dark inside there. May need to touch that up just a bit there. Had to get some more washers for the screws and put the back on. And now we flip it around and put the knobs on, and we should be done. We're going to attempt to demonstrate this, but as you can hear, a lot of static crashing. I've just experienced a pretty good storm here, but we'll try to demonstrate it. Look how close those stations are together. It's about almost 4 p.m. Hear those static crashes with lightning. Another station. Getting close to our good one. Blast us out.
You've started thinking about what to wear this fall?
I want to get over and get some sideband and some CW. Show you the HF bands, how they work and how that BFO works. Should be right along here, should be another station somewhere. Not getting it. Should be one right down in here. Right there. Okay, let me flip over to the high frequency bands, shortwave bands, and we'll pick up some single sideband. Okay, there's a single sideband. Let's turn the BFO on. See if we can tune him in. There's the other station in there. So let's try to get some CW now. Zone 20 meters, 14 megahertz. Yikes. Lightning. Turn the BFO off. That's all you can hear. Just thuds. All right, let's go and conclude the test. I believe it turned out pretty good. I want to thank everybody for watching, all the comments, and I really appreciate it. And so there wasn't much of a demonstration because of the thunderstorm, but it was picking up static too. But it's going to be fun, especially this fall and winter, and setting up. I'm going to set this up and just play with it like a little shortwave listening set myself. So, from Larry, from the hills of Tennessee, thanks for watching.